This is exercise 3A, page 64. Have a look at the functions. We've got a quadratic function, y equals ax squared, the green function, and a is greater than 0. We have a log function, y equals ln x, the blue function, and it does pass through 1, 0 as we expect. If the x-coordinate of the point of contact is b, explain why those two equations. So we've got to get two equations. So let's put b into for x. So if we put b into the first equation, well, first of all, equate the two equations because the point of contact is common. So we'll have ax squared equals ln x. And then the point of contact is when x equals b, so ab squared equals ln b. And if you reflect back on the question said show or explain why ab squared equals ln b. So ab squared equals ln b, common point of contact is the reason. And then we've got to think of something else that is equal, and because the two curves have a common point of contact, at that point of contact they have a common tangent with a common gradient. So let's find the gradient of the first function. So to find common gradient, of the tangent at the point of contact, we do the derivative of the function ax squared with respect to x will be 2ax, and the derivative of the ln a or the ln x function with respect to x equals 1 on x. Now at b, these are equal. At x equals b, the gradient of the first function equals the gradient of the second function. Therefore, 2a, and instead of x, we're putting in b, is going to equal 1 on b. And if we refer back, that is the equation. So that's the common gradient. We'll call that equation 2. And up here, common point of contact was equation 1. Part B was to show that the point of contact is root e and a half. So we look back at our two equations to see how we can eliminate variables. 2ab equals 1 on b, and up here ab squared equals ln b. So if we multiply both sides by b in equation 2, we'll get 2ab squared equals 1. And that's just a rearrangement of equation 2. And if we compare it to equation 1, we've got ab squared equals lnb. So if we make both the subjects ab squared, so here's equation 2, we'll ab squared equals a half. And this is just a rearrangement of equation 2. Then the ab squareds we can make equal. lnb equals a half. And we want to find out what b is, so let's take the exponent of both sides. So e to the ln b equals e to the half. The whole point of exponential and natural log are their inverse functions, so e to the ln b is b, is going to equal e to the half, which can be expressed as square root e. And remember, that's what we're trying to show, so it's looking good. So now in just one of the functions, we want to put root e. If we put it in the ln function, then that's likely to simplify. So ln of root e equals y. We want, sorry, here we go, here's the original equation. We want y equals ln x, so y is going to equal ln e. So let's leave e as the fractional power, and we get a half. So the point of contact instead of b, we write root e, and instead of y, we write a half. So I've just rewritten some of the information to help us find the value of a, which is part C.